interest in this is very much the same as what brought me into Unix in the first place. Oh, geez, it's going to be a tough hour. You'll have to bear with me. I started computing about 25 years ago, another 2 weeks. And I was in the PC community. CPM wasn't quite out yet. PETs had built-in OSs, and that was about it. And I learned every operating system that came on an micro. Not that I would real less what was on most of them with the operating system. About the time, let's see, it was even before MS-DOS. About 1980, January 1980, I discovered the C programming language. C was interesting to me because I tried to learn Pascal. Pascal was a disaster. I read a book this thick, and I might as well have just eaten it for all that it taught me. I understand what Pascal is for. It's a teaching language. It's there to force you to learn a few things, clearly. I don't think it's very successful at that, unfortunately. So in late 80, I was programming 14 different basics. I was running around causing lots of trouble in a couple of bigger operating systems, but I didn't really have an environment that I called home, a place where I liked to be, my favorite place to do work. And I looked around to see if there was one that I wanted to brush up on and be the best and have this really cool tool. And I stumbled across this paper that I mentioned the other day for those of you who are here. And it was a paper written by some people at Berkeley. And actually, I believe it was published by the Bell System Technical Journal, which was good of them. And the paper simply said that this Unix operating system was going to go out and have VM added to it. There was this team at Berkeley that was going to have virtual memory. And they wanted to take a look at the history of VM. In this case, it's virtual memory, not virtual machine. This was really interesting to me because one of the things I noticed in that point 5 or 6 years in the industry was I noticed every PC vendor, and this is before the IBM PC, this is back with personal computers, not personal clones. They were all reinventing the wheel. They all had to learn from each other. Excuse me, they all refused to learn from each other. It was a lot like today's situation when you go out into Freshmeet or open source directory and you find 5, 10, 20 projects all doing the same thing over. And you look at this and you go, well, I can understand there being a couple, but why are there so many? And the Unix community impressed me from the very start as a community that was trying to learn as best it could, whatever resources it could. There was a little bit of competition. The Berkeley people were just emerging versus the AT&T people. That was okay. A little bit of competition, not a huge amount. There was a little bit of cooperation. There was a little bit of exploration of the past. There was a little bit of, screw the past, I'm going to do something new. And all of these were a good mixture. And I found Unix to be a really cool tool. By the time 1981 rolls around, I'm beginning to use Unix. I'm a C programmer. I completely dropped using BASIC. And everyone looks at me and goes, Hugh, why are you doing this? Don't you know the future is Pascal and BS? The future. I'm not going to tell you what the future is this summer. Matter of fact, with my voice the way it is, I'd like to make this even more of a discussion because you folks might know more of the future than I do. But what I do know is I've been for, 10 or more years now, maybe 15, looking for the next cooler tool, the next better tool than Unix. There's got to be something out there. We've got to develop it. It's going to come someday. What is it? How's it going to work? What is the shape of it? Those are details that have to be worked out. I have some ideas, I have some understandings, I've watched a few people try, and I'm going to talk about that this hour. But the idea here, and talking about this in this forum, is that the Linux community is a very vibrant community. There's lots of energy here. I'm hoping that this energy gets better focused, thus my talk yesterday about software quality, but I'm also hoping that this community can do something that hasn't been done since the 60s, and that has come up with a new way of doing computers that's even better than the last way. And the reason I think it's this community that matters is because I do not believe, I need more. I need a rotor-rooter for my throat. Please. The blood scares people. The reason I think this community is important is that I do not think that a version OS, a brand new OS, is going to have any chance of succeeding in the current OS climate. If you take a look at how much we expect out of computers today, we expect an awful lot. We expect that they're robust when we buy Microsoft. We expect that they're well designed when we buy Microsoft. We expect, there's a large list of things like this. We expect networking. We expect virtual memory. We expect that a user expects that any system he gets will just play his DVD backwards for him. And that's a really high barrier to jump. My suspicion, and I've told this to my friends who are doing advanced OS development, is that the right thing to do is to take Linux and make it a process in future OSs, so that all the tools that people are addicted to, and let me assure you, everyone in this room, maybe not even me disincluded, is over-addicted to their current tools. We proved this when James Gosling and the team of people around him, and some others of us, did the news operating system, the entirely PostScript-based operating system, and people flipped out. They couldn't stand the PostScript-based, forth-based programming language. And James, 3 projects later, ended up going off and doing this work called Java. That's an opinion in mine. So I'm all the way over here from America. I'm here to make opinions. If you don't like it, talk to me afterwards. So what are the proper? So we're going to need to jack a new OS under Linux, and we're going to need to have Linux there so that we have all the tools that we're familiar with, compilers, and this group only wants to use Emacs. This group only wants to use XEmacs. This group only wants to use Vim. That group's still using N. Believe me, it's true. So the OS is going to, I think, grow up from a new community. I think you see the beginnings of that sort of effort with the real-time kernels, which are jacked under Linux, and are a fairly cool idea. The real-time kernels aren't good enough in and of themselves because they're like Mensas. Do you have Mensa here in Europe? Yeah, okay. If you ever play with Mensas, most of them are super brilliant if you define brilliant as being about, a millimeter wide across the whole section. And they'll walk up to you at a party and they'll take their millimeter breadth of brilliance and they'll slice you in half and go, aha, I'm smarter than you. Right? Of course, by now, you've pushed together vacuum welded the seam, but they don't notice. So they prove they're greater than you. And they go off and live whatever lives they live. The real-time OSs, I think I see the same problem. They're solving one thing, and that is real-time embedded systems needs. And they're not doing anything else. And that's not good enough for what we need. Some of the things we need, let's talk about this. We need security. All right, I'm really embarrassed. I never mentioned this yesterday, But I'm really embarrassed to be in communities that are suffering from so many buffer overflows. This is really awful. That's yesterday's talk. Tomorrow's talk is, or today's talk, it's tomorrow, I'm gonna just put tape over my mouth. Today's talk is about what OSs should do. And unfortunately, one of the things the OSs are gonna have to do is a massive amount of security to make certain that even if you do buffer overflows, you cannot damage even that application. And that's a tough calling. That's what I just described as computer science. Let's describe this. I kind of see three ways of doing things. There's pure raw inspiration, okay? That's when you sit down and you go, I've got a better idea than that old fuddy-duddy up front, and I'm gonna do it no matter what he says. Go for it. There's science and engineering. They're two different things, and they feed off of each other. Literally, science uses engineering practices to discover things, methods that weren't known before, and to quantify them and to explore their shape and usefulness. Engineering is simply the discipline of taking what science has discovered, feeding it into a repeatable, known form that can be applied, hopefully without killing too many people. One of the guys at NetHack isn't a software guy. He's training. He says an aerospace engineer. And he told me one day, my job is to kill people dead. That's what aircraft engineers do, unless they're really good. And I think it's true for us. I think you'll find our software is ending up in more and more frightening places, running in more and more critical systems. So, once again, the talk yesterday, the talk today. Thank you. Which reminds me, because I turned mine off. No one knows me here anyway. No one knows my number. There we go. Okay, so we're going to have to deal with security. All right. Another thing we're going to have to deal with that's in the realm of science, I'm talking about science now, is negotiation. Something computers are going to really have to start doing is they're going to have to deal with resource exhaustion. Right now, it really looks like we've got infinite amounts of memory. And we do, compared to where I started, at least I remember building 4K memory cards. We don't know how to negotiate. If you look at the disaster that I work with called Ike, it doesn't negotiate, it demands. It says, I want this, or I won't talk to you. Telnet, which is from, who remembers when the Telnet draft was written? 1979 or 81, somewhere deep dark in the past. Telnet actually has a fairly good idea of negotiation. There's science to be done in figuring out how two entities negotiate. Some of this work was begun around a group at George Mason University in Washington, actually in Virginia. And they called it agoric open computing. And the idea behind agoric computing is that everything in a computer could be a market. So that your process might be given a bank account and it might have to buy various resources. And different processes might make trade-offs. One process might go, well, I want lots of swap because I only need a little bit of data at once. Where another process might go, well, swap isn't important to me. I need a minimum amount of memory. But what I really need is I need to have CPU every so often. And right now, we sit here and we try to write general solutions to these problems. And Unix has done better than most other OSs. But that won't do in the future when we want our machines to be able to play 10 MPEG video porn movies at once without jerking. Right? It's got to, oh, well, jerking might be what that was after. But anyway, we need to do this because there's always going to be resource exhaustion. And right now, the OS has no idea what an application wants to do. So, for instance, I can have two applications running in memory at once, and one needs to look at the same data set again and again and again, but it's big, right? And the other is fesking the disk, reading everything on the disk. Well, the one reading everything on the disk is going to trash the one in memory. And there's no way to negotiate how this is going to work. So that's the next level. Another level of what is still science is and this is frightening that this is science, is what I call DFA, Design for Administration. It's especially egregious when you get to security protocols and when you get to things like auditing. How do you know that a system is operating correctly? How do you, when you've got secure communications, and the idea behind secure communications is that if you don't negotiate secure communications, you don't talk at all. If you don't talk at all, how do you discover why the secure communications fail? This is a real interesting problem. I'm trying to get the people in the ITF to think about it now. Unfortunately, that's the ITF. That's a place that's supposed to be the Internet Engineering Task Force, not the Internet Science Task Force. Here's an area where Linux people can go off and try things. Some of us have read too many academic papers, some of us have read not enough. That's a really cool combination because meet in the middle, try different experiments, try different things, something might come out of it. Another problem that is only at the borders of science is secure booting and identification of a system. How do you bring up the system and know that you are not the second operating system on the machine? That you're not, in some sense, second virus, such that you can trust your machine. There was some work done in digital, back when there was a digital, on this, and they had some cool things where unless the operating system is absolutely certain that it was the first operating system and that its checksums matched and no one had fooled with it since it last booted, it couldn't get its identity out of the hardware. There was a little bit of hardware added with RSA public and private keys, and unless the OS could prove to itself that it was sane, it couldn't get its own name, which is an interesting quantity. Whether or not that would work on mass market PC clones like this one, I'm not certain. There is some work out there that's interesting. There's been a raft of little things recently I haven't looked at too much. Things like at the OS or the OS, a couple others. There's been things like BIOS, Next Step, Mock, GNU Herd. The GNU Herd is definitely off in deep space somewhere. We've been waiting for it for a decade, and I still haven't even seen it running once. There's a couple operating systems that I really think understand the sort of thing that needs to be in the future. And it's interesting because I think if I say the words, you'll hear the words and you'll go, oh, I know what that means, and you'll miss it. The operating systems that we need to build have to have this distinction I've been talking about a lot recently between mechanism and paradigm. BIOS is amazing as far as mechanism is concerned. It's got objects, and it's got message passing, and it's really cool because it's got all the latest, coolest tools. If you sit down at BIOS, my question is, how do you use it?
Like Unix.
Like Unix. Well, then why don't I run Unix? What did all this change, and what did all of this message passing and objects, what did it buy me?
Maybe it brought you a new methodology or a new perception.
Okay, I'm asking what it is. I'm not asking
Why do you
maybe.
want to know that when you design it? Why would that necessarily optimize the system?
What I'm trying to explain is that there's more than mechanism to an operating system. You use the word methodology. That's not bad. I use the word paradigm. It's how you use the tools. If you go to different workmen's shops, you'll find very similar tools. There'll be a screwdriver in a woodworker's shop, and in my electronics shop, and in his refrigerator repair shop, right? But we use these tools in different ways. We have methodologies that we use these things in. And people often focus on the mechanism because it's easier than the paradigm and the methodology that you can use. And my claim about BIOS is that cool experiment, but if I'm just going to use it the way I'm going to use Unix, why should I bother switching? Is it one? Please raise your hand, but and I'll be happy to take input. Oh, okay, now you, I guess. Oh, no, you, next to you. The other you.
Okay, the other me is not here. When correctly applied, new mechanisms might add better properties and stability and performance and speed to the existing methodology of using the system. I'm not sure whether BIOS has done that the correct way, because I don't know enough about it to actually make that kind of claim. But I would be, in a real world environment, I would be happy if I would have the same interface with a better set of mechanisms underlying it.
Okay. What I'm talking about here, what I'm trying to get you folks to see, is that if I've got the same interface, if I'm using the same methodologies, if my paradigm hasn't changed, then all I'm doing is changing the library underneath, and I'm not winning anything fundamentally new.
So you're stuck in a lot of respects.
You're stuck in a lot of respects, right? And as much as I love Unix, as much as I've been a proponent of Unix for almost 2 decades now, and seriously in front of the industry at sometimes, like a cat in front of an 18-wheeler, I see that Unix has its limitations. I see that we've done things wrong, that we've left our paradigm. One of the things I'm working on proposing now is an entire replacement for sockets. Get rid of sockets entirely. Sockets are not Unix. Sockets are the sort of thing you'd see coming out of Windows. All right? They're just a steaming pile of function calls that you need lots of ioctls to control. All right? So I'm talking to people about doing something where you play 9-bit, which is control files versus file files, and backing a lot of the messiness out of that interface, and also making the interface more flexible at the same time. And the great wedge for me to get to talk about that is that we have to add security to our APIs. And the security can't be black and white security like it's so easy to add. It has to be security where I can say, I trust this, but only a little. And that's a complex thing, right? And also you're going to need to negotiate between programs and APIs. And we're back to negotiation. How does an API negotiate with the quality of a piece of information is? A real simple example is we're going to have secure DNS in the future, right? But what if you're off the net at the moment when you request an address, and that address is in cache? How good is that data? How much do you trust it? Especially if it comes from a dynamic DNS system, right? You need to have qualities attached to your data, which just aren't there in the current universe. And part of what I'm trying to do is I'm trying to see what better ways of thinking about network communication can I get by replacing the paradigm with sockets. So when you tell me BIOS used just like Linux, I kind of go, well, great, okay, it's another proprietary Unix. Why bother when I've got Linux and I can go under the hood in Linux if I have the time to fix things and change things as I need. I'm talking about going further than that. I'm talking about new ways of thinking. And I'm going to talk about one as an example because it's one I know really well. And it's one that I think you guys think you know, and I do not believe you do. It's what's called a capability-based operating system. Capabilities, I've looked at them a little bit in Linux, and they didn't really seem anything like what I'm familiar with capabilities. They are also patches on the current system. There are 2 capability-based OSs that we know of. There are probably more that have been done by the spook organizations worldwide, and it'd be interesting to find out what they've done someday. certainly in the US, we should pry them open and get some value out of the research we paid for.
Or ask them,
What?
or just simply ask them.
Have you ever asked a question of one of our lords in the spook agencies? I did recently, right? I asked them, are they using security enhanced Linux? And they said, we can't tell you. I said, fine, then you don't count. I looked at them and said, look, if you can't be part of the community, if you can't share your research, we're going to consider what you're building a hangar queen. Nice, cute experiment, but we're going to go off and do real work, right? Security enhanced Linux doesn't look like much anyway. Their presentation at OLS, was that only 2 weeks ago?
Yes.
Was not very well done. Their languages were very poorly laid out. They hadn't coalesced. The collation mechanism of taking their security and trying to turn it into policy was exactly the same model as Unix already uses. You notice they had 3 possible states, which equated exactly to other group and user. I want to get back to capabilities, if I may. A capability-based operating system, there have been 2. One was built back in the 70s, and it was called KEYCOS. Keys being a shorter word than capability, which I mean short. The other is an ongoing project in the free source community, which I actually have helped found, although I've had almost exactly nothing to do with, called Eros, which is an attempt to do a capability OS under the GPL in today's modern world on PC clone hardware like this. And so it's quite exciting to me, because I think it's something, especially now that it's under GPL, that we can push forward. What's the capability OS? The guy who developed these ideas the most is a guy by the name of Norm Hardy. Great guy, wonderful kids. Just the perfect grandfather at this point, as he's getting on in years. He developed this OS at, oh God, I don't even remember the name of the company. There's a company that's based around it now that's failed 3 times. He developed this OS, and it ended up being the only OS that NSA ever bought externally. And there was actually a period where they would only buy machines that ran KEYCOS. The problem is, how do you understand a KEYCOS? Well, I spent 4 days with Norm trying to get him to explain it to me. It took 4 days. And it turns out it's actually very simple what a capability-based OS is. A capability is the ability to talk to something. If you can't interact with something, then you can't have an effect on it. Now, capabilities turn out to be really useful, because if you implement an operating system that, instead of having its paradigm as processes, pipes, files, which is what Unix is, or objects and message passing, which is what BIOS is, or we can talk about herd or anything. They implemented an operating system where everything was a capability. So a process was simply the capability to use some CPU. And capabilities had little meters, and you could kind of fill them up or empty them out. So if I wanted to freeze a process, and I had the capability to communicate to the capability table that controlled processing, I could just zero out the process's capability to essentially buy CPU time. There was no monetary agoric mechanism. There was just this ability to zero out the counters that allowed you to do something. If I wanted to get it a hunk of memory, I could ask the thing that handed out memory, can I have a hunk of memory, please? And it would hand it a hunk of memory, and my capability only allowed me to have that hunk of memory. And this turned out to have some amazingly interesting properties, because you could zero things out and start them up again. It turned out that it was trivial to do something that doesn't make any sense, but it was trivial to freeze the entire OS for a moment, take a picture of the state of the whole thing, and then start it up again. Thus, they ended up with the ability of being able to freeze the OS, take the hardware down, change things, bring the hardware back up, bring the OS back up, tell the OS that things have changed, so that if anyone had asked for the capability to be informed if things have changed, they could get that, and then continue running. Now, when I first found out about that, it was, wow, that's cool. Most of you just looked at me and went, man, so it's a laptop. They had machines that they instantiated, in their term IPL, because this was IBM 370 hardware. They had machines that they ran continuously. They IPL'd once and ran for over a decade. Show me a Linux box that can do that. Okay, now these machines were secure. I don't think you really want to be bored by the analysis, but once people are introduced to this style of capabilities, and they start thinking about security, they kind of go, wow, was I dumb? I was trying to do security some other way. The people who are really security weenies just get excited about capability OSs because there's nothing else that makes sense once you know this, that it's going to be secure. Both the Linux people, the Linux security model, and the security enhanced OS model, the capabilities aren't fundamental, they're patched on. And because they're patched on, there are ways underneath them. I think you'll always find there are ways underneath until you put stuff on the top. A little cute aside here, just linguistically, the Eros version of this, which is a modern implementation, like I say, key cost is from the 70s, they ran on 360, I guess, hardware. The Eros project started off doing, we're going to do real mechanism. So we're going to program the whole thing in C++. They're now in the middle of rewriting the whole thing in C. They needed to get work done, and C++ is a great mechanism, but there's so much of it that it interferes with each other. It's a little bit like some of you have tried to bring up your own waveland, and Paul has come and whacked you on the head and pulled the plug out of your waveland, right? C++ is so much mechanism that the brightest people I know in programming don't know how to use it. So sometimes it's really important to have a clear, focused mechanism that makes sense and you can do new things with.
Things in this capability-based operating system there is conflict, or is that never happened?
There is actually never conflict because the capability environment says that I have the ability to do this, right? And I can say, I can ask for a piece of memory that no one else can do anything with.
What happens if two things need the same thing?
Well, it's a binary tree, you can't get there, right? Two things can request it, and the first thing might get it, right? And the second thing might bounce. And what we need to add to capabilities is agorics, right? We need to add a market where the first guy buys it, and the second guy would have to buy it from the first guy to get it, all right? But it turns out one of the cool things about capabilities is that you can have the capability to pass capabilities on or not, right? So I as an OS might hand you a device, okay, and say, here's access to this space, right? And then you might want access to that, right? And he might want to sell it. But for security reasons, I haven't given him the ability to resell it to him. Okay? Part of the idea behind capabilities is that you can't have this conflict, right? Because if the conflict happens, your OS stops working, and you stop knowing exactly what's going on, which is really important to these OSs, that we know what's going on. One of the things I say is never let the machine win. We're people, we're better than that. Whenever you let the machine win, something's really wrong. Other questions? Yeah. Okay, that's,
Repeat the question, please.
okay, he's asking, how do I define a capability? Okay? There's lots of details about how KeyCost does capabilities. And there's details that are different about how Eros does capabilities. There's things in Linux that are now called capabilities, which are really just fine-grained access permissions, very similar to what security enhanced things is doing. When I talked to Norm for 4 days, 1 month, I brought him up one day every week to San Francisco and grilled him. Because, you know, here's this really cool guy, he's friendly, he's full of information, he's twice as old as me, and he knows something I want to know. And I fed him a good dinner, and I said, okay, what do you think of this? There's a lot of mechanism I'm not going to go into. I'm not even qualified to go into because I've forgotten something about it. But fundamentally, capability is the ability to interact with something. If I don't have the ability to interact with something, I can't fool with it. So if I have the capability for one hunk of memory, and you have the capability for another hunk of memory, all right? And I want to go fool with your hunk. In a capability system, I can't. There's just no way. Because my capability for memory is for the left hunk, not for the right hunk. You know how VM works a little bit, how we get each our own memory spaces, right? And there's a mechanism down in the hardware, luckily, that enforces the fact that I can only write in my memory space and I can't write in your memory space, right? This is why the Palm is uninteresting and the Agenda VR is interesting, right? Because the Agenda I can use as a crypto token, I can write cool programs because memory spaces are separated. In some sense, a capability operating system is that sort of enforced distinction applied to everything you can imagine in a computer, applied to CPU resources, applied to hardware devices, applied to memory, applied to disk space, applied to software services. Mentioned.
That you can pass on attributes with the capability.
Well, that's another capability, is the capability to pass on a particular capability.
Okay, so I can start timestamps on it, or CPU loads, or even capability to pass it on, or
Well, you know, since I'm talking about what could be, and you're welcome to contribute to the Eros project, which I was going to go dig up the webpage for, so that you can see it. You could add anything you wanted. Eros does things differently than KeyCost did. So it's not one fixed design. It's a paradigm of how you do things. All right. So hold on, I'll get to you next. In Eros, in KeyCost, there weren't timers on things. Once you had the ability, you had it forever, right? But there was always someone above you who owned your resource and could zero it out temporarily. They could turn it off. So you had the capability, but it was null and void. It's a little bit like if you're caught drunk driving, they'll null out your driver's license for 6 months, but you still got it, right? Because anyone that looks at it goes, oh, you got a driver's license, but you can't use it. Okay? That's how KeyCost dealt with it. Eros, and I don't know the details because they can change it. My apologies. I'm a little busy trying to get free swan happening, but I'm also trying to seed your minds and your community with this good ideas and good stuff. You're next?
how do you keep it? Sorry.
No, I just misidentified you as the guy below you.
Okay. How do you keep the system from, or the OS from preserving large amounts of resources? And if you try to counter that, how do you keep it from getting a huge overload of overhead for keeping all those things in check? In other words, if I have a processor requests a certain amount of memory, and it's assigned, but it doesn't really use it just yet, how do you actually, how are you able to use that memory for another process after all?
Okay, first off, if you have a hierarchy of ownership of capabilities, right? and you prune the hierarchy, you garbage collect what's below it. So if the process goes away, the resources become available. I believe we call this recycling. So that's a real trivial answer to this. I had another answer, but I think that does it for now. Does that answer the question?
Actually, the process might still be done, but it's perhaps not using all.
And the process can relinquish the capability, right? You see, imagine if we can get capabilities merged with agoric systems, right? Where you have a capability and it's not only it's got a price that comes with it, a value, right? And then when a process is done, or when a process is done, say editing that big image, and now wants to display it, right? It might want to sell off some of the memory so it can buy more video bandwidth. And you know, mind you, don't be scared by the idea of market-based computers, okay? Capitalism, to some of us, is using your resources to the best of their advantage. And money is only one resource. What I'm trying to do right now is use another resource, goodwill and the intelligence of my community, to push the operating system design. I consider myself a capitalist today, while I give out all these great ideas, hoping the return is larger. Yeah? The problem is the capabilities aren't the basis of the OS. And so you'll find, you notice we have the Bastille system, or not Bastille, jails. Linux, played with these jail systems for a while. What? Oh, well, there was a version for Bastille for a week called Dungeons or something like this. Somebody built a system on top of the old paradigm, and it turned out there were too many ways to tunnel under and screw it up. Okay. In all honesty, I just, as much as I love Linux, well, Unix, not Linux this week. No, seriously, try running 2.4 on an IBM laptop. The best thing I could do is turn off APM, and then it almost worked. I don't think that you can patch. No, I'm going to say this stronger. You cannot patch security on top of an old OS. It will not work. No, okay. There's a difference between reinventing the wheel. This is my criticism of BIOS. My criticism of BIOS is that it is simply Unix with a different mechanism. When I asked how do you use it, I was told just the way you use Unix. Okay, I look at this and I go, it's got a different mechanism at the bottom, it's got the same paradigm at the top, and I'm not winning any new security, any new abilities particularly. And the same goes for adding all this stuff to Linux. It doesn't buy me agorics. It doesn't buy me fundamental security. It doesn't buy me fine grain control of the resources. I wanted to respond to one other thing that was asked, and that was my concern over overhead of a system like this. There's two responses to that. First off is ECOS and ARIS are incredibly lightweight compared to what Linux and BSD and Solaris have become. On the other hand, they don't serve 50 communities and have 3 networking stacks and all this garbage. The other thing is, what the fuck do you care, right? Your laptop is over 500 megahertz, has over 128K of memory. I could go on, right? It doesn't matter in some sense. You might care about percentage usage of the system. All right, let's look at the percentage usage. I have a half gigabyte of memory in this laptop, okay? How much is Linux using? Oh, maybe, 10 megs for anything at all vaguely related to code near the kernel, right? Probably more like 5, okay? It's a non-issue. The other thing that frightened me that I didn't like was some research I saw looking at the early time-sharing systems and looking at the amount of resources they used and what the win was for using those resources. And it was disturbing me that operating systems, time-shared operating systems in the 70s, that were willing to burn 10 to 15% of the CPU, were actually getting more productivity out of the system than operating systems that were trying to keep under a percent of the CPU. There's a synergy, there's a win from having these resources managed in a reasonable way.
What happens if you're designing operating systems for places like third world countries that are using recycled hardware, therefore, yeah. And are there people that are doing this, they're bearing that in mind about, let's say, emerging economies that are now severely disadvantaged. Let's not talk about colonialism right now, but they're receiving our recycled hardware. And is there any part of the coding community that is addressing this issue so that they can work in a very comfortable way with our recycled hardware?
I'm going to answer you with my opinion. I hope not. Yes, I hope not. Don't do colonialism again, please. Don't colonize them with inferior OSs that we wouldn't use.
I didn't say it was inferior, I said maybe actually smart.
No, okay, hold on a moment. Okay, let me look.
There are some projects going on, like building operating systems for people that cannot read.
Well, okay, that's an interesting project I don't know about. Accordingly, I'd like to know, or send me the URL for that one. There are some interesting projects based on our current OSs that are bubbling. There's talk of building a Linux distribution that is focused on human rights workers everywhere in the world. So the things that you want to worry about are things like multiple languages, things like robustness, and Linux is anything if not completely brittle. All right, so we need to deal with the brittle issues of Linux and Unix in general. The real key here is that Rwanda today has more computing power than the entire United States in the 70s. Okay, literally from our thrown off hardware. All right, Rwanda has more power than more computing power in its nation than it took to design the most advanced nuclear missiles and weapons of the 1980s. I'm serious. All right, the people have bugged me for years about the issues of, oh, well, shouldn't we tax hardware to give it to the poor? Well, if you tax hardware to give it to the poor, I can assure you who's going to be deciding what hardware goes where and how much of the overhead goes to the big corporations. Right? What matters isn't the hardware, isn't even so much the software, it's the training and communication and the ability for our experience to rub off on others. Okay? There's a guy in Jamaica who's got this really cool idea. He got himself a 40-foot by 8-foot by 8-foot container. Right? Real standard thing, easy to move around, ship, the whole bit. He's outfitting the entire thing as a road, internet, ISP at one end of the building, workshop, and then classroom cafe. And his idea is to drive this thing around Jamaica, park it in a village for 3 months, teach the locals about computing, and then move on to the next set of locals, right? Hopefully leaving a little bit of hardware behind, maybe a little bit of pirate infrastructure to get away from the cable and wireless monopoly, and start getting these people communication systems, start getting them the tools. And you know, it wouldn't matter if we were dropping 286s on these people, okay? Because compared to a stick in the mud, a 286 is amazing, all right? And you know, the next thing that's gonna happen after the 286 is we're gonna be throwing out our P4s for P15s, right? And we're gonna, if we're bright, we can give them, continue to let this hardware flow. And you know, someone's gonna complain, oh, well, we're giving them all the high power stuff and trying to ruin their power infrastructure. Or, oh, we're trying to fob off our pollution problem on them. No, we're giving them better tools.
You're talking about hardware, you're talking about operating systems.
Right. The operating system, no, look at the third world, the second world, the real world, whatever we want to call it, will be far more served by having the same tools, Linux, OpenBSD, FreeBSD, NetBSD as we do. They will be far more competitive, right? They will be far more, if we give them a different OS, right, then they're gonna have to learn something different. They can't come out here and get jobs. They can't use our tools there. You know, we're trying to build, some of us, a single foundation for a planet-wide human community.
That's what I'm suggesting. People are designing, for example, a capability-based operating system, they're also entirely.
No, I pay attention to the entire system. Right? I can't, it doesn't fit in the design, okay? Let's explain something, okay? If you're from India, if you're from the Outback, if you're gray, pink, or purple, you compute, you have a brain. The male ones might be different from the female ones, the Eastern ones might have some different paradigms from the Western ones, but when it comes to thinking about systems, it's all the same. There is no difference between us. Maybe this is one of the most important things about computing and about the internet, is that it brings us together on a plane where, as someone once said, no one knows you're a dog. Yeah, it's Q&A time here. I'll try to dig up the website for you.
There's always been a performance issue with not very much commercial being attached to employees secure operating system. Is it only now with all this spare computing power and we've reached a stage where we've got so much to spare that people should stop thinking about performance and start thinking about security?
There's those of us who've argued that we should always have thought about that.
Absolutely, but it's been a drive for performance. It's not underlying new things. There's always thought about is how much more performance, but also we should trade in that for security.
You know, I'm going to state something. I don't think that there's more than 10 people in this entire campsite who understand how to measure performance. I'm serious. I don't think there's more than 10 people in this weekend's community who have a clue what the performance difference is between Linux and OpenBSD. It's been a focus of ours. It's been something that we've talked about. I don't believe it's particularly real. I don't think there's a real fundamental difference there. Well, let me try to answer your question, sir. What I'm trying to get at here is that we need to do systems engineering the way you bring engineering, where everything matters, because everything gets there in the end. The pointy-haired bosses, of which I unfortunately am one, they all want performance. They all want, it all done yesterday so they can fire you, or something like this, right? What we're talking about here is how to design things that are useful entirely. Let me be very explicit about this, okay? I'm going to space. I will live in my lifetime free of this planet's gravity. I might not get to the stars anytime soon, but I'm at least getting to the asteroid belt, okay? Linux is not the OS that will drive my spaceship, okay? I would be dead if I used software the way we do. That was yesterday's lecture, okay? Today's lecture is we have to design better systems. Here's some things I know and I've learned. Let me throw them out because you've likely never heard of them. All right? Yes, the systems have to perform, but Moore's law says don't fucking worry about it. Okay?
That's what I'm arguing. We now have so much performance that we can trade a lot of things that used to be performance.
The key,
Better engineering.
right.
Better.
The key costs people made this trade in the 70s. The Multics people made it in the 60s. I'm trying to say that we're always greedy for more CPU. If this were the gamer crowd, rather than the Linux crowd I was talking to, they'd look at me aghast and go, what? You want to take away 5% of my voxels? No fucking way! All right, they flip. On the other hand, the gamers have a big problem because it's too easy to go into the systems and modify things and cheat now. And they're beginning to realize this with network games. So maybe they'll come around next. And what I'm trying to say, yeah, right, maybe.